This video will cover Section 8.2 on testing a claim about a proportion. Your objectives here will be to perform a hypothesis test for claims about a population proportion and be able to interpret the results in context using common language. Our first example is a drone example. We have a technology journalist writes in one article, "It is clear that a majority of consumers are not yet comfortable with the idea of a drone delivering their packages." A survey is conducted where 1,009 consumers are asked, "Are you comfortable with the idea of a drone delivering packages to you?" 545 of them, or 54%, responded no. Can we use this survey to support the claim of the journalist? So we'll be looking at a z-test for a population proportion. The big question here is, if the true population of people are uncomfortable with drone delivery were exactly 50%, how surprising would the results be in the survey? So you have to think about there, if it was exactly 50%, that's saying half of the population is uncomfortable. We are going to use a hypothesis test called a z-test to answer these questions. Requirements will be that the statistic meets criteria of a binomial distribution, and n times p is greater than or equal to 5, and n times q is greater than or equal to 5. Our steps for a z-test for p, or population proportion, is to write a pair of hypotheses and label the claim. Make sure that you are stating your null and your alternative, labeling them the correct way, and labeling which one is the claim. You'll identify or specify the level of significance, or your alpha. Draw a graph of the sampling distribution, indicate if it is a two-tailed, left-tailed, or right-tailed test. So this will look like your standard normal distribution, and then just shade in whichever tail it is, or if it is a two-tailed test, you'll shade both tails. Calculate the test statistic. So we know that p hat is the sample proportion, and p is the proportion that will be in your null hypothesis. Q, of course, is 1 minus p, and n is the sample size. So to calculate our test statistic, you'll do z equals p hat minus p divided by the square root of p times q all over n there. Okay, so this is a formula that you want to make sure you know how to do. And I will be writing it out, but of course you can, or you will be putting this into Excel to get your calculations. So our steps continued. You'll then find your p-value, and for a right-tailed test, you will use, now these formulas are the norm.dist, where you're entering then the 0 and 1. Remember, your other thing could be norm.s.dist, and then you'll just put in your test statistic. So again, for a right-tailed test, we'll do 1 minus norm.s.dist, and then that test statistic. For a left-tailed test, you'll do norm.dist, and then just your test statistic. For a two-tailed test, if the area to the left is a negative test statistic, or you'll do right of a positive test statistic. So you'll have to look at, is it a positive or negative, and then decide which way you do. So again, if it's a negative test statistic, you'll go to the left. So that means you'll do just norm.s.dist. And if it is a positive test statistic, you'll do to the right, so you'll do 1 minus norm.s.dist. Just make sure that you end up doubling the area when you're doing a two-tailed test. Then you're going to make a decision about your null hypothesis. You'll either reject your null hypothesis or fail to reject your null hypothesis. So just remember, if the p-value is less than or equal to alpha, you reject your null. Okay, so these are key things here. And if the p-value is greater than alpha, fail to reject your null. Your last step is to write your interpretation. Make sure you're using common language and you're putting it in terms of the original problem. So you saw a table like this in the 8-1 example that I completed for you guys for that assignment in practicing writing null hypothesis and which one is the claim, finding out the tail and all that. So just make sure this is a table that I would come back to regularly whenever I am writing an interpretation. So you'll have to decide what is your claim. Is it your null hypothesis or your alternative hypothesis? And then what was your decision? So if your claim is your null hypothesis and you said reject the null hypothesis, then you would use there is sufficient evidence to reject the claim that, and then make sure that you put it in terms of the problem. So I usually start mine because we always want to state our level of significance with at the level of significance. So whatever that level of significance is, there is sufficient evidence to reject the claim that. I may also, so you may see it written as alpha is whatever, there is sufficient evidence to reject the claim that. Again, just make sure that you do include your level of significance and then you write your interpretation based on the problem. So here we're back looking at the drone delivery example, and we know that the article stated it is clear that a majority of consumers are not yet comfortable with the idea of a drone delivering their packages. And we have the survey where 1,009 consumers were asked, are you comfortable with the idea of a drone delivering packages to you? And 545 of them responded no. We're going to test the journalist's claim at alpha equals 0.05. So the first thing we need to do is figure out how to write our hypothesis. We know that a majority of consumers means greater than 0.5. So because it is a greater than 0.5, we're going to make that our alternative hypothesis. So P is greater than 0.5, and this is our claim. So the null has to be less than or equal to 0.5. The next thing we need to do is state our level of significance. So I always like to write that down. And we know that alpha is 0.05, and then draw your sampling distribution. So you would draw the normal curve, and because our alternative hypothesis is greater than makes it a right-tailed test. The next step is to calculate your test statistic. So p hat in this case was the 545 that responded no over our n of 1,009. P will be 0.50. Again, this value is coming from our null hypothesis. And then, of course, Q is just your 1 minus P. N is 1,009. So now you're going to plug in to the formula for the Z. So 545 over 1009 minus 0.5 over the square root 0.5 times 0.5 over 1009. If you put this in Excel, you would get 2.55. I will go back and do a little video or something for the Excel part of this. I think most of you guys are pretty comfortable with this, but I do want to make sure you have something to go back to. Step 5 is to calculate your p-value. So we know that our p-value here is going to be z is greater than or equal to 2.55. So you can do 1 minus norm.dist, that test statistic value 0, 1, 1. Remember, this just means true. Or 1 minus norm.s.dist 2.55. You will get the same answers here. And if you put that in Excel, you should get 0.0054. So now we want to make our decision about the null. So that means we're comparing the p-value to alpha. So we have 0.0054 compared to 0.05. So 0.0054 is less than 0.05, which means our p-value is less than alpha. So we will reject the null hypothesis. Our last step is to write our interpretation, and here is one written out for you. At a 0.05 level of significance, there is sufficient evidence to support the journalist's claim that a majority of consumers are not yet comfortable with drone delivery. So if you go back and take a look at the hypothesis test interpretations table, you'll see first I stated what my level of significance is, and then because our claim was the alternative and we made the decision of reject null, then you are just filling in there is sufficient evidence to support the claim that, and then you're putting in the terms of the problem. Here we have another example. A dating app uses the following statement in an advertisement, and 40% of adults are not married. Find your soulmate today. A recent survey found that out of 512 polled adults, 225 of them are unmarried. Test the claim in the advertisement at a significance level of 0.05. Okay, so the first thing that we are going to do is write our hypothesis, but we need to figure out what is this. Okay, so we're talking about a population, and we see that it says 40% of adults are not married. So that means P equals 0.4. Okay, that will be our claim. So I'm going to go ahead. Let's go ahead and write our hypothesis. We know that the null hypothesis is P equals 0.4, and this is our claim from the advertisement, and our alternative would have to be P is not equal to 0.4. And alpha here is 0.05. Then you're going to sketch your sampling distribution. And because it is a not equals to in the alternative, this will be a two-tailed test. I like to jot down just what my P is, remember P is coming from your hypothesis. Q is 1 minus P, so that's 0.6. P hat is how many? So P hat, so we had 225 out of 512. And our N, of course, is 512. So now we're going to use that information as we find our test statistic. So Z equals P hat minus P over the square root of P times Q over N. So 225 over 512 minus 0.4 over the square root 0.4 times 0.6 all over 512. Put this into Excel and you get approximately 1.82. Now we're going to use our test statistic to find our p-value, and because, just as a note, remember that Z is 1.82 and this is a two-tailed test, so because Z is positive, you're going to use the right formula for finding p-value, so equals 1 minus norm dot S dot dist 1.82, and this is 0.034, and then remember you have to double because it's two-tailed, so that gives you 0.068. Then you have to make your decision, so let's compare our p-value 0.068 to our alpha 0.05. 0.068 is greater than 0.05, so fail to reject the null hypothesis, and then we'll write our interpretation. So at alpha equals 0.05, there is not enough evidence to reject the ad's claim that the proportion of adults who are unmarried is 40%. We have another example of finding a job. So a university makes the following claim: at least 90% of our students find a full-time job in their major within 1 year of graduating. So at least 90%, that we know is going to be greater than or equal to 0.90. A student group conducted a poll. They asked a random sample of 204 recent graduates if they found a full-time job in their major within 1 year of graduating, and 173 of them said yes. We are going to test the university's claim at a significance level of 0.01. This is our alpha, and then we can find our p-hat by doing the 173 over the 204, which is n. So writing our hypothesis. We know that the claim said at least 90%, and we said that is greater than or equal to 0.9. So that makes our claim the null hypothesis. So the null hypothesis, P is greater than or equal to 0.9. And our alternative is going to be P is less than 0.9. Alpha here is 0.01. Sketch your sampling distribution. Since our alternative hypothesis is less than, then this will be a left-tailed test. And what we're doing is we are finding this Z, and then our p-value, of course, is here. Again, I'm going to write in what we know. P here is 0.9, making Q 0.1, P hat 173 over 204, and N is 204. Our Z is 173 over 204 minus 0.9 over the square root of 0.9 times 0.1 over 204. And you'll get in Excel approximately negative 2.47. Now we're going to use that z-score, that test statistic, to find our p-value. So we'll do equals norm dot s dot dist and negative 2.47 equals 0.0067. Make your decision. So I'm going to compare my p-value to my alpha of 0.01. So 0.0067 is less than 0.01. This means we reject the null hypothesis, and then write our interpretation. So at alpha equals 0.01, there is enough evidence to reject the university's claim that at least 90% of graduates find a job in their major within 1 year of graduating. That ends section 8.2 on testing claims about a proportion. Your lab manual pages that go with this is pages 79 through 81. Let me know if you guys have any questions. At the end of the week, I will have an assignment for you guys of with mixed problems from chapter 7 and chapter 8.